Hello and welcome to Anthropology Academy. Today we are going to discuss about radiocarbon dating, which is an absolute dating method used in prehistoric archaeology or archaeological anthropology. Let us first try to understand the historical development of radiocarbon dating, or commonly known as C14 dating. In 1939, Martin Kamen and Samuel Rubin conducted an experiment to find out the half-life of radiocarbon, that is, a radioactive isotope of carbon. Later on, Sergei A. Korf predicted for cosmic rays and C14 production. He hypothesized that C14 is produced by the cosmic particles bombardment in the upper atmosphere. In 1945, William Libby started his work on radiocarbon dating. In 1946, Libby hypothesized that living matter contains 14C, that is the radioactive isotope of carbon. In 1947, experimentally proven that 14C is present in sewage but not in petroleum. In 1949, Libby, along with his colleagues, successfully dated mummies from Egyptian tombs with known age, and the difference between the actual age and the predicted age using C14 was minimal. And for this discovery, in 1960, Libby was awarded the Nobel Prize in Chemistry. Now let's move on to the physical and chemical details of radiocarbon dating. We can see that carbon has three different isotopes: 14C, 13C and 12C, out of which 12C and 13C are called non-radioactive isotope and 14C is the radioactive isotope of carbon. This radioactive isotope is produced in the upper atmosphere using a nuclear reaction. That is, stable nitrogen isotope is bombarded with neutron, and 14C is produced along with a free proton. Now, this carbon isotope goes through a radioactive decay over a period of 5700 plus minus 30 years, which is the half-life of carbon 14 isotope. In this radioactive decay, carbon 14 isotope is transformed into stable nitrogen atom, emitting an electron and an electron antineutrino. The principle of radioactive dating is simple. First, the living organisms intake C14 isotope through gaseous exchange, maintaining an equilibrium. That is, C14 ratio is constant with the environment. The C14 ratio should inside the organism should be kept constant along with the environment. However, gas exchange between the environment and the organism stops when the organism dies. For the dead organisms, C14 intake stops and the 14C and 12C ratio decreases. What it means is that for living organism, 14C along with 12C, this ratio of these two isotopes inside the living organism remains constant. However, for dead organisms, as time moves on, as time elapses, 14C, due to its radioactive nature, it gradually decays, and the ratio between 14C to 12C inside the dead organism reduces. There are four dating considerations for radiocarbon dating. First one is the variation in the 14C-12C ratio in the atmosphere, both geographically and over time. Second one is the isotopic fractionation, which is also known as 12C and 14C ratio. Third point is variations in the 12C and 14C and 12C ratio. in different parts of the reservoir. And fourth one is the contamination of 14C isotopes with other isotopes of carbon, that is 12C and 13C. There are 5 carbon reservoirs there are 5 carbon reservoirs in the environment, as we can see: atmosphere, terrestrial biosphere, surface ocean, dead organic matter, and deep ocean. These 5 carbon reservoirs have different amounts of carbon 14 isotope, carbon 12 isotope, and carbon 13 isotope. So there are variations in these reservoirs in terms of 14C and 12C ratio. Now let's move on to types of materials that can be dated using radiocarbon dating. Normally, wood sample that can be reduced to cellulose component can be dated using radiocarbon dating. Unburned bone, the collagen part of the bone can be dated. For burnt bone, which is already carbonized, that can also be dated using C14 dating method. Shells from marine and land organisms, calcium carbonate, can be dated. Peat, which is composed of humic acid, humins, and fulvic acid, can be dated. Soil, which is associated with organic samples, can be dated. Any other materials such as ivory, paper, textiles, individual seeds and grains, straw from within mud bricks, and charred food remains found in the pottery can be dated using C14 method. Limestones can be dated using C14 method. However, for limestones tools, if the limestone has been transformed or cut into tool, then that tool cannot be we cannot use C14 dating method to estimate when that stone was cut into tool. We can date the material. Remember, we can date the limestone, but we cannot date when the limestone was cut into tool. Now, coming to the instruments used for measurement of C14 decay, there are 2 different kinds of instruments that are used in this dating method. First one is called beta counters, and there are basically 3 different types of beta counter. One is called the Geiger counter, which was used by William Levy as the first detector. Another counter was called gas proportional counter, and there is another counter which is called liquid scintillation counter. The second category of instrument is called accelerator mass spectrometry, hereafter referred as AMS, which is more sophisticated and nowadays more frequently used than other beta counters for C14 dating. As you can see, if the material has gone through gasification, then we can use gas proportional counter. If the material has been liquefied, then we can use liquid scintillation counter. And if the material is solid, then we can use accelerated mass spectrometry. Accelerated mass spectrometry, or AMS. Now, there are some sample sizes, prescribed sample sizes to be used for C14 dating. For example, if we are using whole wood, then for beta counters it will be 10 to 25 grams of sample to be used for coming up with accurate dating. And for AMS, we just need 0.05 to 0.1 grams of material. Similarly, for charcoal, we can use 10 to 20 grams of material, but for AMS, we just need 0.01 to 0.1 grams of material. For bones, we need 100 to 400 grams of material, but for the AMS technique, we just need 0.5 to 1 gram. So you can see that for different materials, there is a different requirement for the sample sizes. The calculation is done in two different ways. It depends on the technology used. As you can see, for beta counting, samples radioactivity or beta particles are counted. Radioactivity is compared to a standard sample with known radioactivity. For example, for oxalic acid, the radioactivity is known and the radioactivity is unknown for the sample under dating. So we can compare the beta particles emitted from the sample with the oxalic acid and come up with a statistical figure. But for AMS technique, 14C to 12C ratio in the sample is compared to 14C to 12C ratio in modern sample. Here modern is referred as 1950. Followed by the counting of beta particles, there is a stage called error rates estimation and calibration. For error rates estimation, there can be sources of error in the sample itself. And fundamentally, there are three sources of error: statistical estimation error, C14 level of the sample itself, and laboratory storage, preparation and measurement. After calibrating for these errors, we can have a curve, and using this curve, which is also known as a calibration curve, we can measure the estimated calendar age of that sample based on the C14 particles remaining, C14 radioactive isotope remaining in the sample. There are different calibration curves prepared by different organizations, international organizations. One of them is called INTCAL, the other one is SHCAL20. For underwater samples, there is a thing called Marine 20. So these are the different calibration curves used by different agencies and for different materials. The date is reported in two different ways. For an uncalibrated date, the format is reported as laboratory sample ID followed by a colon, then year plus minus range BP. Here BP stands for before present, that is the reference date of 1950 AD, which is also called zero date. The date is zeroed at 1950 AD, and anything that is before 1950 AD is called BP. The laboratory that tested the sample and the sample ID is required in uncalibrated format, followed by the age in radiocarbon years, estimation of the error that is presented in the range. So you can see an example. UTC is the laboratory that tested the sample and the sample ID was 2020, UTC-2020 colon 3510, that is 3510 years plus minus 60 years before 1950. On the other hand, for calibrated dates format, cal date range confidence. This is the usual way of reporting a calibrated date. For example, cal 1220-1281 AD 1 sigma. This means a calibrated date or a true date lies between 1220 AD and 1281 AD with a confidence interval of first sigma, that is the first standard deviation. Now comes the archaeological applications of C14 dating. C14 dating can be used to measure key transitions in prehistory. For example, the end of last ice age, beginning of the Neolithic and Bronze Age in different regions, Holocene or Pleistocene boundary that was dated as 11.7 thousand years before present using C14 dating. Dates obtained from African hunter-gatherer settlements 50,000 years before present. From early farming villages in the Near East, materials were dated successfully. and materials from the Americas and from the cities and spectacular temples associated with early civilizations were also dated successfully. Notable recent applications include 38 skeletons from Mediterranean migrants in India found at Rupkund Lake in the Himalayas. They were dated to be within the period of 800 CE and 1800 CE. It was published in Nature journal in 2019. Another very interesting work was the Shroud of Turin. It was alleged to be the 1st century relic contemporary to crucifixion of Jesus Christ. However, it was basically an art forgery, and the forgery was detected using C14 dating, which revealed that the material is dated of 14th century origin. Another interesting discovery that was done using C14 dating was the direct dating of prehistoric paintings from Chauvet Cave, France, between 29,700 and 32,900 BP. The survival of Neanderthals till 30 to 40,000 BP was also confirmed using C14 dating. And another interesting discovery was the Alps glacier mummy, which was also known as Utzi, found in 1991. It was thought to be of at least it was thought to be of last decade. However, it was dated to be old as 4,546 plus minus 17 BP. So these are some of the interesting findings that were discovered using C14 dating. Now, C14 dating also has some limitations. That is, radiocarbon dates can be obtained only from organic materials. We cannot date inorganic materials. Relatively few artifacts can be dated. For example, the wooden handles or all the shell jewelry. Very few bone or any artifacts made of bone or flute made of bone can be dated using C14 dating. Only contemporary artifacts associated with organic materials, hearths or with abundant charcoal, broken animal bones and burned wooden structure. Any inorganic material can only be dated if it is associated with an organic material, provided the inorganic material is contemporary to that organic material. Another limitation is the limit of measurability is approximately 8 half-lives, that is 45,000 years. Samples older than this will typically be reported as having an infinite age. Oldest dates that has been obtained using radiocarbon dating with some of the sophisticated techniques and finest calibration curves is around 60,000 to 75,000 with isotopic enrichment and large sample size. So finally, we come down to the conclusion that radiocarbon dating is an absolute dating method with high accuracy. Radiocarbon dating is also known as a radiocarbon revolution because this discovery has let us uncover many histories of the past, especially in the archaeological and paleoanthropological context. It has far-reaching applications with minor limitations. In some cases, some medical applications were also found to estimate the age of some tumors or some soft tissues. And future refinement, future research is currently ongoing in this field using isotopic enrichment to expand the dating range beyond 40,000 or 50,000 years. So these are the references that you can use or you can go through to further enrich your knowledge. Thank you for listening to this lecture. I hope you will find it useful for your studies. If you have liked the video, if you have liked the materials, then please subscribe to this channel click on the bell icon and press the like button. And you can also share the video if you have liked it. So till next time, thank you very much and bye bye.